I want to show you an example of creating a confidence interval where I actually have to get the data myself. So I've been asked, or I'm asking us, to construct a 90% confidence interval estimate for the proportion of orange Haribo gold bears. So I have a bag of what I would just call gummy bears here, but technically Haribo gold bears that are, by the way, delicious. And they come in the flavors of orange, strawberry, pineapple, lemon, and raspberry, and everyone knows the orange ones are the best. So I'm concerned with the proportion that are going to be orange, and I'm going to use this bag of these Haribo Gold Bears as my sample, and I'll get my sample data from it. So what will we need to know? Well, I'll need to know a value for X, and that will be the number of orange bears in here. I'll need to know a sample size, and that'll be the total number of bears. I'll use those two things together to calculate a sample proportion. And I already have a confidence level chosen of 90%, and so I need a value for Z sub alpha over 2, that critical value, and at the 90% level, that's 1.645. And you might be wondering why I picked the 90% confidence level, and there are a couple of reasons. Number one, I haven't done an example at 90% yet. Number two, this isn't a real important situation in life. We don't have to be so sure about the proportion of orange bears, right? If this was something in a medical field, I'd probably want a higher confidence level than this, but I'm just counting bears in a bag. After I have all that information, I'll be able to calculate my margin of error. I'll add and subtract that to my point estimate p hat. And then we'll have our confidence level. And then I'm going to stop the video and eat this bag of gummy bears. All right, so let's count what we need to count. All right, make sure I get all of the bears out of the bag. I don't want to cheat anything, so make sure the bag's empty. The bag's empty. All right, and this isn't supposed to be a commercial. I'm not being paid, but these are delicious. So what I'm going to do is I'm going to sort these into their various flavors. And then we'll need to get a count of the orange ones and all of the bears. So hopefully I can do that pretty easily. I invite you to make your own problem like this by going into the pantry and grabbing a favorite candy. There's nothing special about the gold bears for this activity other than the fact I like them and I had a bag of them. That's probably the most important part for this video. These existed and I didn't have to leave the house to get anything. All right, so one bag is my sample here, and to have more validity here, I need a larger sample, probably many bags. But let's count the orange ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 orange ones. I'm just gonna double check that. 2, 4, 6, 8, 10, oh, something's wrong. 2, 4, 6, 8, 10, 12, 13 orange ones. This is why you always check your data. All right, let's see, these are the pineapple ones. 1, 2, 3, 4, 5. And I don't need the individual counts here, but it'll make it easy just to go through and count them this way. 1, 2, 3, 4, 5. If these were your favorites, you would be sad by this particular bag, and I don't know if these proportions hold out over many bags. That would be a separate question. All right, many green ones. So I'm going to group them here by, let's see, 4s, just to make it easier to count. And at least one person watching the video is saying, why would you use 4s? Group them by 5s, but I'm going to commit here to the 4s. So 4, 8, 12, 16 green ones. And now I just need to count the red ones, and to be less of a monster, I think I'll group these by 5s. The grouping by 4s definitely seemed to work last time, but that was luck. All right, so far this video is just seeing if I can count things, and so 5, 10, 15, 20, 21 red ones. So if the red ones were your favorite, you are in luck. All right, since I messed up counting this one once, now I'm paranoid and I don't want comments that I can't count. 6, 7, 8, 9, 10, 11, 12, 13. All right, I've confirmed that one. I feel good about it, and that is our value of x, since I care about the orange ones. And by saying I care about the orange ones, I literally mean I care about the orange ones. They are, in fact, my favorites. All right, now I just need to add these values together to get a value for n, a total number of bears here. So let's see, 5, 10, 31, 31 and 16 more, 47, and then 13 more. That would be a total of 60 gummy bears in the bag. Now, because I want to make sure I didn't get that wrong, I am going to just off camera here add them up in my calculator just to double check it, and I got 60 a second time. All right, so I have my data here. I've got everything I need summarized here. I need to calculate a sample proportion. So I'll save these for later. And we'll construct our confidence interval. P hat, x over n, 13 out of 60. Oh, I think writing that as a decimal is not going to hurt. So 0.21, and 6 repeating. I'll round this to 0.217 for simplicity's sake. Q hat, 1 minus P hat, as a fraction, that would leave me 47 out of 60. And if I wanted to write that as a percentage, I could subtract that or just do the arithmetic here and get 0.783. I'm ready to calculate my margin of error. All right, and I think I'm going to key in the actual fraction so I don't have to round anything, though I don't think we're going to increase the error here too much by using the rounded figures. All right, let's see what happens here. 1.645 times the square root of 13 out of 60 times 47 out of 60 divided by 60. 0.087. There's my margin of error, and now I want to construct my confidence interval. So I need to take my sample proportion and add and subtract this value. So 0.217 plus 0.087. And then 0.217 minus 0.087. I'm 90% certain that the true proportion of orange Haribo Gold Bears is between 0.13 and 0.304. There's my 90% confidence interval. I challenge you now to use your graphing calculator to check this result the way I showed you in the last video.